In this video, we're going to take a look at some more examples of simplifying square root and higher root expressions. So picking up where we left off from the last video, example 3D, we have the square root of 65x to the fifth. So we can separate that as the square root of 65 times the square root of x to the fifth. And square root of 65 can't be simplified any further than it already is. So with square root of x to the fifth, we have an even root. So it's the square root is 2. 5 divided by 2 is 2 with a remainder of 1. So the remainder stays inside the root as x to the first power, and then the quotient of 5 divided by 2 is 2. That power of x, that 2, gets pulled out of the root. So the square root of x to the fifth is x squared times the square root of x. And as we saw in the last video, you could put the absolute value of x squared times the square root of x, where the square root of x is not inside the absolute value bars. But it isn't necessary when you have a second power for x squared times square root of x here. So multiplying and simplifying what we can, only x squared is outside of the radical, so we have x squared times square root of 65x. Part E, cube root of 27x to the seventh. So we can break that up as the cube root of 27 times the cube root of x to the seventh. And the cube root of 27 is 3. And we are dealing with an odd root here, so we want to avoid absolute value bars completely when we have an odd root, like a cube root. 7 divided by 3 is 2, so that's the power of x that we take out of the radical, x to the second power. The remainder is 1. 7 divided by 3 leaves a remainder of 1, and that's the power of x that remains behind, still trapped inside that cube root. So we have 3 times x squared times the cube root of x gives us 3x squared times the cube root of x. Again, notice, odd roots like cube roots, we do not use absolute value bars at all. All right, part F, we have the cube root of 128x to the sixth. So that's the cube root of 128 times the cube root of x to the sixth. And for the cube root of 128, we'll take 128 divided by these first column values, but instead of being squared, because it's cube root, they got to be cubed. And looking down this column, the lowest positive integer we have is 2. So the cube root of 128 is 4 times the cube root of 2, because the largest perfect cube that goes into 128 is 64, which is 4 cubed. So the cube root of 128 is 4 times the cube root of 2. So we have 4 times the cube root of 2, and then power divided by root, 6 divided by 3 is 2. Again, it is a cube root, so we're not going to use the absolute value bars. So 4 times the cube root of 2 times x squared gives us 4x squared times the cube root of 2. All right, that about does it for this video. Thank you for watching. I'll see you next time.